So welcome everybody to this latest video on 162 Maths, and in this video we'll be going through the GCSE Maths practice paper for 2023 higher set for paper 3, which is a calculator paper. Now as always I'll include a question breakdown so you can see which topic refers to which question to aid your revision. So let's get started on this practice paper of 2023 set for paper 3, which is a calculator paper. So looking at question 1, it says reduce 360 by 12.5%. So what we need to recognise is that by reducing we start with 100%, and if we're reducing by 12.5% then what we're wanting is 87.5%. So to work out 87.5%, what I need to do is just multiply the amount by the decimal multiplier of 0.875, in which if I type that into my calculator I get the correct answer of 315. Then moving on to question 2, it says simplify. So all I need to do with indices here, and I've got brackets, is multiply the powers. So it's going to be 6 times 3, which is x to the power of 18. Moving on to question 3, it says the bearing of A from B is 225 degrees. Work out the bearing of A. So what it is we're actually wanting to work out is what this angle here is going to be. So to do this, what I need to do first is recognise that angles around a point add up to 360. So this angle here is going to be 360 minus 225, which gives me an angle of 135. Then I know that because I've got two north lines, that these two angles here are going to be supplementary or co-interior. So angle A is going to be 180 minus 135, which is 45 degrees. Now because I need to give it as a bearing, I need to give it as a 3-digit number, so therefore the correct answer is going to be 045. Then moving on to question 4, it says the diagram shows the results of a survey of 1,200 British motorists. The percentages in the survey are given to the nearest 1%. Work out the smallest possible number of motorists who thought electric cars were a good idea. So if it's been rounded to one decimal place, if I divide 1% by 2, I get 0.5%. So then to work out the upper and lower bound, it's going to be 63 plus or minus 0.5. Now the lower bound is going to be 62.5%. So then to work out the smallest possible percentage, where it's going to be 0.625 multiplied by 1,200, and that gives me an answer of 750. Moving on to question 5, it says the direct route between two airports A and B is 690 kilometers. An aircraft leaves A at 6:30 and arrives at B at 8 o'clock. Work out the average speed of the aircraft, assuming that the aircraft travelled in a direct route. So looking at this, we should know that speed equals distance divided by time. So the distance travelled is 690. We want to work in kilometres, and we want the time in hours. So that's going to be 1.5 hours. So then if I type that into my calculator, I should have the correct answer of 490 kilometres per hour. It then says, in fact, the aircraft went an alternate route and still arrived at 8 o'clock. What does this mean about its average speed compared to your answer in A? Well, for this, if we imagine we've got A here and we've got B here. Now, in part A, it took a direct route, so it just went straight. Now, in this part, it's actually going an alternate route. So an alternate route will automatically be longer, but it arrives at the same time. So in order for it to travel further and arrive at the same time, it must travel faster. So you want to write something along the lines of that it would have travelled further but taken the same time so must have been travelling at a faster speed. So something along those lines would be absolutely fine. Then moving on to question 6, it says Oren writes 5 squared times 5 squared times 5 squared equals 5 to the power of 2 times 2 times 2, which equals 5 to the power 8. What is wrong with his method? Write the correct answer. Well, the issue that Owen has done is that he has multiplied when he should have added the powers. So that statement there would be worth 1 mark. And then for the second mark, we need to give the correct answer, and it's going to be 5 to the power of 2 plus 2 plus 2, which is 5 to the power of 6. Then for question 7, it says write these numbers in ascending order. So in ascending order, we want to go from smallest to the largest. So this number has already been written in ordinary forms. We then need to convert this middle number into ordinary form. So move the decimal point 2 places, so that becomes 982. And then this number here becomes 9810. So writing these, I can either write the numbers in ordinary form, or I could write it in the form that it's given to me in the question. So I tend to prefer to write it in the way that it's given to me in the question. So it's going to be 9.82 times 10 to the power 2, 9.81 times 10 to the power 3, and 9,812 rather. Then for question 8, it says solve the simultaneous equations. So here we're looking at the x's and y's. We've got the same number of x's and they're the same sign, so we take away the 2 equations. So 3x take away 3x is nothing. 2 minus minus 1 is positive 3. And 10 take away 13 is minus 3. So that means that y equals minus 1. Then if I pick one of the equations, I'm going to go for this one here. So here I've got 3x minus y equals 13. So I've got 3x minus minus 1 becomes plus 1. So then I've got 3x equals 12. Divide by 3 and I get x equals 4. Then moving on to question 9, it says that the diagram shows a cuboid and its diagonal. The formula to work out the length of the diagonal in centimetres is a squared plus b squared plus c squared, all square rooted. Work out the length of the diagonal when a equals 8, b equals 5 and c equals 3. So all we're doing is substituting these numbers into this formula. So it's going to be 8 squared plus 5 squared plus 3 squared. And now you can enter all that in your calculator, or you could simplify it so it becomes 64 plus 25 plus 9. But ultimately what you should end up with is 7 root 2. So you can write your answer as 7 root 2 in exact form, or you could write it as 9.9. And if I just quickly write down all the values of what it is, then what we should end up with is 9.899494937. So I've rounded it up to 1 decimal place. The next question then says round your answer, input A to 2 significant figures. Now you may have already done this, but basically the correct answer should be 9.9. Then for part C, it says work out the length of the diagonal in terms of A. So here we know that A equals A, B equals 4A and C equals 8A. So if I just remind myself of the formula, well, the formula is A squared plus B squared plus C squared. So from this I've got A squared plus B, which is 4A squared, plus C, which is 8A squared, and that's all square rooted. Then simplifying that, I get A squared plus 16A squared plus 64A squared. So then collecting all the like terms under the square root, I get 81A squared. Now the square root of 81 is 9 and the square root of A squared is A, so my final answer is 9A. Then moving on to question 10, it says the diagram shows 2 circular arcs with centre O, and it says how much longer is the big arc from the small arc. So here the small arc is this here. Now it's a little bit dubious, this question, because they've got an arc over the 60, but this little orange arc is the small arc and this length here is the big arc. So don't worry about this one here, because that's just representing what the angle is going to be. So from this, what we need to do is know the formula for the length of an arc. So the arc length formula, which you need to remember, is theta over 360 times 2 pi r, or 2 pi times d. So looking at this, with the big arc, we've got a radius of 42 centimeters, and with the small arc, we've got a radius of 30 centimeters. So then working out the arc length of the big one, that's going to be 60 over 360 multiplied by 2 multiplied by pi multiplied by 42, and if I type that into my calculator, I get 14 pi. Then with the small arc, let me just write that again. So we've got small arc, that's going to be 60 over 360 multiplied by 2 multiplied by pi, but this time multiplied by 30. Type that into my calculator and I get an answer of 10 pi. So then the difference is going to be 14 pi minus 10 pi, which is 4 pi, and I could write that as a decimal, so it's going to be 12.566 or 12.6 centimeters, and that's to 1 decimal place. Then moving on to question 11, it says, after landing, an aircraft is delayed in reaching its parking stand. The aircraft uses 15 kilograms of fuel for each minute of a delay. 1 litre of fuel is 0.8 kilograms and fuel costs 92 pence per litre, which is ridiculously cheap at this moment in time. Now work out the cost of a delay of 12 minutes. So first things first, what we need to do is we need to work out, well, how many kilograms, what's the weight of the fuel is going to be. So the amount of fuel is going to be 15 times the time, which is 12 minutes, and that gives me an answer of 180 kilograms. I then need to work out the amount in litres. So for this I'm going to do 180 and I'm going to divide it by 0.8, and that comes up to a total of 225 litres. Now the cost of that is 92 pence, so then the cost is going to be 225 multiplied by 0.92, because I want the answer in pounds, and that comes up to an answer of 207 pounds. Then moving on to question 12, it says rearrange the formula. So what we want to do is want to make S the subject. So first things first, what I do is I get rid of the u squared and take it to the other side, so I end up with v squared minus u squared equals 2as. Now rather than taking things individually, I want to get rid of this 2a. What's the 2a doing? It's multiplying. So to get rid of it, I divide by 2a. So what the answer is going to look like is going to look like v squared minus u squared, all divided by 2a, which equals s. Then moving on to question 13, it says data about the height and the interquartile range of tomato plants are given in the table below. Some of the plants were given fertilizer, and it says compare the unfertilized plants to the fertilized plants. Now with the two comparisons, you want one statement to be comparing the mean and the other statement to be comparing the interquartile range, or the spread. So comparing the mean, you want to have something along the lines of that on average. You want to make sure that you are using that word on average. The fertilized tomatoes were taller. And again, although it's only going to be worth 1 mark, I would probably write down how do you know this, and this is because it has a bigger mean. And you could just like 121.9 is greater than 114.6. Then for the comparison 2, we're looking at the interquartile range. We're looking at the spread of that. Now there's a couple of statements you could have. you could say that there's less variation in heights with unfertilized, spelled that wrong, with unfertilized tomatoes, and this is shown by a smaller IQR. And again, if you want to quote the values, then that's fine, 25.7. Or you could say something along the lines of that the heights of the plants were more consistent with the unfertilized tomatoes. And again, we want to quote a smaller IQR. And there we go. So anything along those lines would be fine, but I strongly would say, even though it's only worth 1 mark, always try and state what mathematics you're using to prove that statement that you are claiming. Moving on to question 14, it says here is a box plot. The first question is asking us the range. Well, the range is going to be this value take away this value, so it's going to be 80 minus 30, which is 50. Then work out the median. Well, the median is this line here, and each box represents 2, so that's going to be 64. And then for part C, it says work out the interquartile range. Well, the upper quartile is 74 and the lower quartile is 38, so the IQR is going to be 74 minus 38, which gives me an answer of 36. Then moving on to question 15, it says work out an approximate solution to this by using the iteration of that. It says start with x equals 1. Now again, what you want to do on your calculator is, if this loads up, yes it does. So here you enter the first value, which is 1. So write 1 and then press equals. And then next what I then want to do is enter the formula, replacing anything with xn with ands. So it's going to be 1 over ands squared, and then scroll across and write plus 2. So my second value is 3, so u2 is 3, u3. Now because it's worth 3 marks, I definitely would write down quite a few values. So the next one is 2.1 recurring. Then u4 is going to be 2.224 ... and then u5 is going to be 2.20 2.2 and then ... And then once you've written down, I would say 3 or 4 values beyond what they've given, you then can just go keep pressing equals until the number on your calculator ceases to change. So here we've got the answer of 2.20556,943, and that's what I'm going to write as my answer. Or it actually does say, so the solution is 2.20556,943. I then want to round that up to 1 decimal place, so my correct answer is 2.2. Now moving on to 6.8, says here is a circle with centre O, and the question is asking us to work out the size of angle X. Well, to work out the size of angle X, the easiest one is to use circle theorems, and knowing that this angle at the circumference is going to be half the size of the angle at the centre, so X equals 2 lots of 48, which gives me an answer of 96 degrees. On to question 16b, it says that M, N and S are points on circle 1, O is the centre of circle 1, RST is a tangent to circle 1, and circle 2 passes through SM and O. And the question is asking, prove that SM is not the diameter of circle 2. So here for this, what we need to do is state a fact. So if SM is the diameter, even though we know that it's not, then the angle MOS is going to equal 90 degrees, because looking at this length here, and if I just draw a point here, that the rule of a semicircle is that the angle opposite the diameter is 90 degrees. So we want to see if this angle here is 90 degrees. So let me get rid of that for starters. So first things first, I know that looking at this triangle here, and knowing that RST is the tangent, that this angle here is going to be 52 because of the alternate segment theorem. Then, as you can see, I've got an arrowhead, so this angle here is going to be 2 times 52, which is 104, and that is again the arrowhead. Now it doesn't ask me for me to explain my answer, or it does actually give reason for your answer. So again, I could say that angles at the centre is twice the size of the, I should say, subtended. So angle subtended at the centre is twice the size of the angle subtended at the circumference. So this angle there is 104. So as MOS equals 104 degrees and not 90 degrees, SM is not the diameter. So something along those lines would be absolutely fine. Then moving on to question 17, it says the density of steel is between 7,750 kilograms per cubic meter and 8,050 kilograms per cubic meter. 1,000 kilograms meter cubed is equal to 1 gram per centimeter cubed. A solid metal object has a volume of 1,430 centimeter cubed and a mass of 9.6 kilograms. Is it possible that is made of steel? So what we need to do is to work out what this question is asking, is to work out the density of this metal object. Now, density is equal to mass over volume. Now, this is one way you don't actually need to do this, but what we need to do is we've got a mixture of units. So what I need to do is I need to work out the density of this metal object preferably in kilograms per cubic meter. So looking at this, we can see that the density is going to be equal to, now looking at the units we've got, is we've got 1430 centimetre, which is the volume, which I've done the wrong way, so let's do the mass first. So it's going to be 9.6 kilograms over 1430 centimetre cubed. So what I need to do is I need to convert those two units into kilograms and meter cubed. Now the weight is already in kilograms, so that's going to be absolutely fine, so I can write 9.6. But what I need to do is to convert cubic centimetres into cubic metres. Now one way of doing this is to try and think of, just imagine you've got a cuboid. It doesn't matter what the size of that cuboid is. And what you want to do is think of three numbers. Now to work out the volume, it's multiplying the height by the width by the depth, and we get 1430. So if I think of three numbers that multiply together to give me 1430, so I'm thinking of, let's go for 143, 10, and let's just go for 1. And all of these are in centimetres. Now this is just a fictitious cuboid that I've made, but it will have a volume of 1430 because 143 times 10 times 1 would give me 1430. Now if I try and draw an equivalent cuboid, but this time what I'm going to do is I'm going to convert all of these units into meters. So then what I then get, well, 143 centimeters is going to be 1.43 meters, 10 centimeters is going to be 0.1 meters, and 1 centimeter is going to be 1 divided by 100, which is 0.01 metre. So then working at the volume in metre cubes, it's going to be 1.43 times 0.1 times 0.01. So here what I've then got is 1.43 times 0.1 times 0.001, or 01 rather, and I get an answer of 1.43 times 10 to the power of minus 3. Now alternately, what you could have done is gone from centimetre to metre. So to get from that to that, I divide by 100. So then going from centimetre squared to metre cubed, I've got to divide by 10,000, and then centimetre cubed to metre, sorry, that should be metre squared to metre cubed is therefore going to be dividing this by 100, so it's going to be divided by 1.100, so that's into centimetres, another zeros into metre squared, and another 2 zeros gives me metre cubed. So then from this I can then do 1430 divided by, and it's going to be divided by a million, in which I still get the same answer of 1.43 times 10 to the power of 3. So then typing this into my calculator, oh, don't know why I've just crossed that off, I was meant to highlight it. So then typing this calculation into my calculator, I get, and I'm running out of space on the screen, so I've got 9.6 divided by 1.43 times 10 to the power of minus 3, and I get an answer of 6713.28, and that's in kilograms per metre cubed. So then what I've then got to do is to compare this number to this range, and as you can see it's definitely outside of that range, so the box I need to tick is that it's definitely not steel, and the reason for it is because 6713 is less than the lower limit of 7,750. Moving on to question 18, it says that a notebook is 3 times the cost of a pencil. 12 notebooks and 16 pencils cost £43.16. Work out the cost of one notebook. So if I start by saying that a pencil costs X pounds, then a notebook is 3 times more expensive, so that's going to be 3x. Then using this notation or this information here, I know that 12 notebooks, so 12 lots of 3x, plus 16 lots of x, it comes up to a total of £43.16. So then if I add up all of those x's, I get 36x plus 16x equals 4316. So then that gives me 52x equals £43.16. So 1x equals 0.83. So one pencil costs 83 pence. So then to work out the notebook price, well, that's going to be 3 times 0.83, which comes up to an answer of £2.49. Then moving on to question 19, it says the diagram shows an empty container of height 38 centimetres and a container consists of a cylinder and a frustrum of a cone. Water is added to the container at a constant rate of 13 seconds. The sketch graph shows the depth of the water as the container fills. The graph is a curve for the first 4 seconds and then a straight line for the next 9 seconds. So here is our graph. And the question is asking us to work out the height of the cylinder. Well, looking at this particular shape, that it's going to fill in the frustrum first and then the cylinder. So the cylinder is going to be 38 take away 21. So if I then do 38 take away 21, and that equals 17. So the correct answer is going to be my first option. The next question then says work out the rate of increase of the depth of water between 4 seconds and 13 seconds and state the units of your answer. So what we need to do for 19b is to work out the gradient of this line here. So 13b is work out the gradient of the straight line. So to work out the gradient, I turn it into a triangle, and it's going to be the height, which is 17, and the time, which is 13 take away 4, which is 9. The units are, well, the height is measured in centimetres, this is measured in seconds. So then the gradient is going to be 17 divided by 9, and I can either leave it as a fraction in which my units are going to be centimetre per second, or I could write it as a decimal, so it's going to be 1.8 recurring, and that's in centimetres per second, or you could write 1.8 centimetre per second to the minus 1. Any of those would be fine. Then moving on to question 20, it says that Amy drew a histogram to show the time taken to complete a task, and the question is asking us to give one reason why it is misleading. So a couple of things in which you could say as to why it's potentially misleading. I would say the most common one in terms of part A is going to be the fact that the axis is broken. So we've got a broken axis in terms of the frequency density. Now, something along the other lines of that the height is not comparable to the proportion, because obviously we're missing part of the graph. You could also say that the scale is not continuous from 0, and so again, these are all viable answers that you could give for that single mark. So then moving on to question 20b, it says here is a histogram showing the times taken to complete another task, and the question is asking us to estimate the percentage of people who took less than 30. Now, though it says estimate, what we need to do is do a mathematical calculation to help us estimate that a little bit more accurately. So before we get started, what we need to do is we need to work out what the total frequency is going to be. So the total frequency is the total area of all bars. So if I just label these bars A, let's not use purple because it's not coming up great. So let's go for A, B, C and D. That the area of A is going to be the frequency density multiplied by the time, so that's going to be 40 times 10, which is 400. Then I work out the area of bar B, which is 25 times 10, which is 250. I then work out area C, which is 45 take away 25, which is 20, so it's going to be 20 times 20, which is 400. And then area D, which is 10 times 5, which is 50. So if I add the total area up, I get an answer of 1,100. So then what I then need to do is then work out how many were less than 30. So if I draw a line at 30, then what I want to do is I want to work out the area of this, the area of this, and the area of this. So the first bar, if I just label this as 1, 2 and 3, then area of 1 I've already worked out, that's 400, plus the area of B, which again I've already worked out is being 250, and then the frequency of number 3, well, that's going to be 5 times 20, so 20 times 5, and if I work out all of that, I get an answer of 750. So then to work out the percentage, and let me use colour I've not used, so then if I just scroll down, so then the percentage of less than 30 is going to be equal to 750 divided by the total multiplied by 100. And if I type that all into my calculator, I get an answer of 68.18 recurring percent. And if I round that up, although it doesn't tell me, I'm just going to round it up to 68.2%, and that's to 1 decimal place. Then moving on to question 21, it says the diagram shows a rectangle split into 3 triangles. The total shaded area is 8.5 centimeters square. Work out the value of x. So first things first, to work out the shaded area, it's going to be the area of the rectangle minus the area of the triangle. Now the area of the rectangle is 3x multiplied by 2x plus 3, and the area of a triangle using base times height is going to be 3x multiplied by the base, which is 2x plus 3, all divided by 2. Now what that then becomes, because obviously the unshaded triangle is half the area of the rectangle, then the shaded area is basically going to be 3x, 2x plus 3 divided by 2. Now the question tells me that this shaded area is 8.5, so then what I then get is that 3x, 2x plus 3 all divided by 2 equals 8.5. Now if I take the 2 over, I end up with 3x, 2x plus 3 equals 17. Expand the brackets and I get 6x squared plus 9x equals 17, and then I end up with 6x squared plus 9x minus 17 because it looks like a quadratic, and I get this quadratic equation once I made it equal to 0. Now because the question says give your answer to 1 decimal place, I'm going to go straight into using the quadratic formula and just assume that it doesn't factorize. Now again, before you do that, what you want to do is make sure that there isn't a common factor to make the numbers smaller, but there isn't, so I'm going to proceed. So I've got c equals minus 17. Then now again, some calculators have got the quadratic formula already programmed, but try and show that you have substituted these numbers into the quadratic formula. So it's going to be minus 9 plus minus 9 squared minus, and I always like to put a bracket around the 4ac, so 4 times 6 times minus 17, not 77, so let me just make that a little bit neater, minus 17, and that's all square rooted, all divided by 2 times a, which is 6. Now if I type that into my calculator, then I get 2 x values of, one is 1.09277, and the other value is minus 2.59277. Now it can't equal this because x can't equal a negative number, so the correct answer, so let me just write x can't be negative, so the correct answer to 1 decimal place is going to be 1.1. The next question then says this 3D diagram represents a piece of wood. The horizontal base ABC is a right angle triangle, CT is vertical, angle ACB is 42, BC is 15.1 and CT is 12.8, and all of those are labelled on the diagram. And the question is asking us to work out the size of angle AT and the horizontal base. So AT is this line here, and the question, what it's asking me is to work out what this angle here is going to be. Now to work out, as you can see, I've got quite a lot of few right angle triangles. So I've got this right angle triangle of TCA, and CBA is also a right angle triangle. ABC rather is a right angle triangle. So first things first, what I need to do is I need to work out what this length here is going to be, which I'm just going to call x. Now to do that, what I need is I'm going to use the triangle ABC. So if I just take that triangle out, that this is A, this is B, and this is C. I know that this angle here is 42, and I know the hypotenuse is 15.1, and this side here is x. So using SOHCAHTOA trig, what I've then got is this is hypotenuse, this is the adjacent, so I'm going to be using cos. So I've got cos 42 equals the adjacent, which is x, over the hypotenuse, which is 15.1. So x equals 15.1 multiplied by cos 42. Now if I type that into my calculator, I can either write 15.1 cos 42, or I can write the decimal equivalent, which is, let's work that out now, which is 11.22148 blah blah blah. Now because that's not my final answer, I'm going to leave, I want to try and add a few decimal places to my final answer without rounding too quickly. So then what I've then got, if I take this triangle out now, this is the angle that I'm wanting to find, so let's just call that y. This is t, this is c, and this is a. Now I know t to c is 12.8, and I've now discovered that CA is this number here, which I'm just going to write as 11.221. Now you could use 15.1 cos 42 if you want to be super accurate, but again you should be okay just adding a few decimals after the 11. So then from this I'm going to use SOHCAHTOA trig, so I'm going to be using tan. So I've got tan y equals, and it's going to be the opposite, which is 12.8 over 11.221. So then working out y, so y is going to be the inverse tan of 12.8 over 11.221, and again you might still have that number on your calculator, and let me just stick a 1 there, and so typing that all in, so inverse tan, set up my fraction, 12.8 over, and then the 11.22, in which I get an answer of 48.8 degrees, and that's to 1 decimal place. Then moving on to our last question, it says the number of bacteria after t hours is given by the formula of n equals a times 2 to the power of 0.15t. And let me just zoom in so we can see that a little bit clearer on screen. And it says where a is a constant. It says at the start of the experiment there are 500 pieces of bacteria, show that a equals 500. Well, this is my value of n, and at the start t equals 0. So if I substitute these two numbers into this formula, then what I end up with is 500 equals, and it's going to be a times 2 to the power of 0.15 times 0. Now this is, the power is therefore going to equal 0, so this is basically going to equal 1. So I've got a times 1 equals 500, so a equals 500, and there we go. It then says for question B, how long to the nearest hour is it before the number of bacteria doubles? So what we're looking for here is, well, if the bacteria doubles, then this is going to be 1000, and the formula is 500 multiplied by 2, 0.15t. So then if I take the 500 over to the side, I end up with 500, sorry, half, or no, it's going to be 2. So if I divide by 500, I get 2 equals 2, 0.15t. Now 2 is just 2 to the power 1, so as you can see the bases are the same, so that means that the powers must be equal to each other. So 1 equals 0.15t, so t equals 1 over 0.15, and if I type that into my calculator, 1 divided by 0.15, I get an answer of 6.6 recurring, and we want it to the nearest hour, so it's 6.6 hours, so then to the nearest hour, this number rounded up is going to be 7. Moving on to our last question, it says that in 23C, Morgan wants to work out that there will be more than 1 million bacteria after 3 days. Is she correct? Well, because the formula is given in hours, what I need to do is convert the days into hours. So that's going to be 3 times 24, so t equals 72. So then if I substitute t equals 72 into the formula, so I've got 500 multiplied by 2 multiplied to the power of 0.15 times 72. And remember, that's a power. So if I type that all into my calculator, I get an n value of 891,443.7768, which is less than 1 million. So the correct box I need to tick is no.